Hello, my name is Joana Moreira and I'm going to talk about nanographene-based photo-immunotherapy. Cutaneous squamous cell carcinoma is the second most common type of skin cancer, being responsible for 75% of non-melanoma skin cancer-related deaths. Despite the significant impact of immunotherapeutic approaches in cutaneous carcinoma treatment, important limitations and side effects still remain, such as toxicity, acquired resistance, or unresponsiveness. Graphene-based materials have immunomodulatory properties, high surface area, radiation absorption and thermal conductivity, being ideal platforms for drug delivery, phototherapy, and immunotherapy applications. In this work, the biocompatibility and immunomodulatory effect of graphene oxide and reduced graphene oxide on primary human monocyte-derived macrophages isolated from buffy coats from healthy donors was evaluated. In Section 2, we discussed the production and characterization of the GBM materials. Graphene oxide was produced from graphite using the modified Hammer's method, followed by ultrasonication. Reduced graphene oxide was obtained through graphene oxide photoreduction. Overall, the materials had a nanometric size, with reduced graphene oxide presenting a smaller size, a less negative surface charge, and a higher capacity to absorb radiation. Section 3 describes the evaluation of cell viability of primary human macrophages using risazorin assays after exposure to graphene oxide and reduced graphene oxide at 100 or 250 micrograms per milliliter for 72 hours, with or without a 30-minute radiation cycle. Overall, it was possible to conclude that the incubation with graphene oxide or reduced graphene oxide at 100 micrograms per milliliter, irradiated or non-irradiated, did not affect the cell viability, being this concentration selected for subsequent studies. In Section 4, we evaluated the immunomodulatory effect of the nanomaterials on primary human macrophages in naive or anti-inflammatory conditions, the latter being induced by IL-10 stimulation as to mimetize the tumoral microenvironment. The quantification of the anti-inflammatory receptor CD163 was performed by flow cytometry and by cell imaging, and the secretion of IL-10 by ELISA. It was observed that both materials in the presence and absence of irradiation promoted the reduction of CD163 expression in the anti-inflammatory environment. Regarding the quantification of cytokines, there was a significant reduction in the IL-10 secreted levels only for the stimulation with graphene oxide under anti-inflammatory conditions without radiation. In conclusion, this work demonstrates that graphene oxide and reduced graphene oxide are biocompatible, reduce the anti-inflammatory environment induced by IL-10, and show a very promising potential for cancer immunotherapy. I would like to thank all the institutions that finance this research and you for your attention.